Hello students, in the previous class we have discussed all about work, its unit and the condition for zero work done, positive work done and negative work done. Now we will discuss about the power. What is power? Power means how much work is done in how much time. That means the rate of doing work. The rate of doing work is called power. The rate of doing work is called power. That means power equal to work by time. What is the SI unit of work? That is joule. SI unit of time, second. So SI unit of power is joule per second, or we can say it watt. Doublet it watt. 1 watt equal to 1 joule by 1 second, or 1 joule per second. That implies if we define 1 watt, what we will say? If 1 joule of work is done in 1 second by a body, then power of the body is said to be 1 watt. It is said to be 1 watt. When a body does 1 joule of work in 1 second, then power of that body is said to be 1 watt. Here, power equal to work by time. We know work is equal to F into displacement. Work is the product of force and displacement. If a force is applied on a body and the body is displaced in the direction of force, then work is said to be done. That means product of force and displacement is equal to work. So we can write here W equal to Fs by T. Also V equal to displacement, velocity equal to displacement by time. Velocity equal to displacement by time. If we separate it, F into S by T. For S by T, we can write V. Hence, power equal to another formula we can put, force into velocity. P equal to FV. Here, watt is equal to Newton meter per second. Watt equal to Newton meter per second, or watt is equal to joule per second. Higher unit of power, 1 kilowatt equal to 10 to power 3 watt, 1 megawatt 10 to power 6 watt, 1 milliwatt small m 10 to power minus 3 watt. Another unit is there for power, that is horsepower. 1 horsepower is equal to 1 horsepower equal to 746 watt. We can nearly take it to 750 watt. If there is not given the value 750, you should take 746 only, not 750. 1 HP equal to 746 watt. This is all about power. Now, in the first video, we discussed work, its unit. Now we discuss power. Then we will discuss energy. What is energy? Energy is nothing but capacity of doing work. Capacity of doing work is called energy. The capacity of doing work is called energy. Energy is of various types, such as heat energy, electrical energy, nuclear energy, mechanical energy, sound energy, light energy, etc. So many types of energy. Heat energy is measured in calorie. Heat energy is measured in calorie. Calorie means what is what? Calorie. 1 calorie, the amount of heat required to raise the temperature of food, 1 gram of water through 1 degree Celsius is called 1 calorie. The amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius, that is called 1 calorie. 1 calorie is equal to 4.186 joule. 1 calorie equal to 4.186 joule, or we can write it to nearly equal to 4.2 joule. What is 1 calorie? The amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius is called 1 calorie. That means to raise 1 gram of water, its temperature to reach by 1 degree Celsius, how much heat energy is required? 1 calorie heat energy is required, and that 1 calorie is equal to 4.2 joule. Similarly, electrical energy measured in watt hour, WH, or kilowatt hour, or kWh. What is watt hour and what is kilowatt hour we will discuss now. We know P equal to W by T, power equal to work by time, and W equal to power into time. This one is energy. Capacity of doing work is called energy. So we can write energy equal to power into time. Or unit of power is watt and unit of time is second. So energy equal to watt second. Watt into second. Here 1 watt hour means how much joule? Here joule equal to watt into second. 1 watt hour equal to 1 watt into 1 hour, or 1 watt into 3600 second, or we can write second, or 3600 watt second. If we write in standard form, 3600 means 3600.0. We will shift the decimal towards left. How many places we have to shift? 1, 2, 3 places. Hence we can write 3.6 into 10 to the power 3 watt second means joule, or 3.6 kilojoule. 10 to the power 3 kilo, 10 to the power 6 mega, 10 to the power 9 giga. Similarly, 10 to the power minus 3 milli, 10 to the power minus 6 micro, 10 to the power minus 9 nano. These are smaller unit, these are bigger unit. Similarly, 1 kilowatt hour, 1 kilowatt into 1 hour. 1 kilowatt means 1000 watt, 1 hour means 3600 second. 36, here 2 zeros, here 3 zeros, 5 zero. So 36 lakh watt second. If we write in standard form, how many places we will shift the decimal? 1, 2, 3, 4, 5, 6. 3.6 into 10 to the power 6 joule. 10 to the power 6 means mega. 3.6 megajoule. Let us suppose if a heater of 1 kilowatt used for 10 hours, then electric energy consumed is equal to 1 kilowatt into 10 hour, 10 kilowatt hour, or 36. 1 kilowatt hour means 3.6 megajoule. 10 kilowatt hour means 3.6 into 10 megajoule, or 36 megajoule. When 1 kilowatt electric heater used for 10 hours, then how much energy will be consumed? Near about 36 megajoule. Similarly, if a 100 watt bulb used for 10 hours, electric energy consumed, how much electric energy will be consumed? 100 watt into 10 hour, that equal to 1000 watt hour. 1000 watt hour means 1 kilowatt hour. 1 kilowatt hour. 1 kilowatt hour means 3.6 megajoule. Understand how the electric energy we calculate? Now we discussed how the heat energy is measured and electric energy is measured. Now we will discuss how the nuclear energy we calculate. Electric energy, nuclear energy is measured in electron volt. Electron volt, or we can say EV. Charge on one electron 1.6 into 10 per minus 19 coulomb. 1 EV is equal to charge on one electron into 1 volt. 1.6 into 10 per minus 19 coulomb into 1 volt, or 1.6 into 10 per minus 19 joule. W equal to VQ, electrical work done equal to potential difference into charge, or joule is equal to volt into coulomb. SI unit of potential difference is volt and SI unit of charge is coulomb. Joule equal to volt into coulomb. We can write volt coulomb. Volt coulomb equal to joule, or 1.6 into 10 per minus 19 joule. 1 EV equal to 1.6 into 10 to the power minus 19 joule. There are so many types of energy we have discussed earlier, and heat energy is measured in calorie. Electric energy is measured in watt hour and kilowatt hour. Nuclear energy is measured in electron volt. Now we will discuss about mechanical energy. Mechanical energy two types. One, kinetic energy and potential energy. First we will discuss kinetic energy. What is kinetic energy? The energy possessed by a body by virtue of its motion. The energy possessed by a body due to its motion is called K. That means when a body is in motion, the work done by the moving body is the kinetic energy. If we calculate what is the work done by the body during its motion, that is the kinetic energy. That is the kinetic energy. Let us Let a body of mass m is moving with velocity v. An opposing force F is applied on the body. Then what will happen? A body is in motion. If we applied force in the opposite direction of motion, what will happen? The body will slow down and ultimately it will stop. When this opposing force F is applied on the body stops. Before the body stops, it will cover some distance. Let the body cover the distances. After covering the distance S, now you see mass of the body is m. Initial velocity is v. First, the body has velocity v, but finally the body stops, means velocity becomes zero. Final velocity, initial velocity u equal to v, final velocity v equal to zero. Distance covered s. Distance covered s. We know a formula in class 9th, v square minus u square equal to 2s, third equation of motion. We can put v equal to 0, 0 square, u equal to v square. Since the velocity of the body gradually decreases, it is decelerated, means dead. We can write acceleration of the body equal to minus a, 2 into minus a into s, or minus v square equal to minus 2s, minus minus plus, or v square equal to 2s. As equal to, we can write v square by 2. Now we will calculate how much work is done when it comes to rest. That means during motion, how much work is done by the body. Work done by the body. Work done W equal to Fs. F equal to ma. From Newton's second law of motion, F equal to ma. But here we get S equal to v square by 2. We can put S equal to v square by 2. So how much work is done? Half mv square. And this is the kinetic energy. During the motion, how much work is done by the body? Half mv square work is done. And this is kinetic energy. According to the definition of kinetic energy, the energy possessed by body due to its motion is called kinetic energy. Hence, kinetic energy is equal to, we can put half mv square. In this class, we have discussed the power and the formula for power unit, and then we discuss various types of energy and how they are measured. Heat energy is measured in calorie, electric energy is measured in watt hour and kilowatt hour, nuclear energy is measured in electron volt, and then we discuss mechanical energy, and it is of two types: kinetic energy and potential energy. And what is kinetic energy and how we can measure it? What formula we should put to measure the kinetic energy? In the next classes, we will discuss other things. There are so many things: potential energy, work energy theorem, law of conservation of energy, various things we will discuss in the next video. Bye. If you like my video, share it and subscribe it. Thank you.